What should I do if I can't find R32 refrigerant? If you need to recharge a system designed for R32, but cannot find this refrigerant, R410A can be a viable alternative. However, before making the conversion, it is important to consider the following information. A. R410A operates at a slightly lower pressure than R32. B. Using R410A will reduce the cooling capacity of the system, potentially decreasing the refrigeration power by 5% to 10%. This means that the compressor will have to run longer to reach the same temperature. C. R32 is more efficient than R410A, so the conversion may increase electricity consumption since the compressor will need to work harder to reach the same temperature. D. Both refrigerants use POE, polyester, oil, which allows the conversion without changing the compressor lubricant. E. The discharge temperature of R410A is lower than that of R32, so in this regard, the conversion does not present any issues. F. If you decide to use R410A in a system designed for R32, the capillary tube may affect system performance due to differences in the flow properties of both refrigerants. However, you can test the system using the original capillary tube for R32 and evaluate the system's behavior. In many cases, the unit operates satisfactorily. G. In general, R410A requires a shorter capillary tube or one with a slightly larger diameter than R32, although this varies depending on the system. It is recommended to reduce the capillary tube length by 5% to 15%. H. On the screen, we can see typical manifold pressure values for R410A and R32 refrigerants, with a system operating on the low pressure side. These values correspond to air conditioning applications, specifically systems operating with an evaporator temperature of 5 degrees Celsius. We can observe that the system pressure with R410A is slightly lower. I. Remember to charge R410A in its liquid phase until reaching a stable low side pressure. Then, measure the system's power consumption to ensure it does not exceed the manufacturer's recommended levels.